Question 9 is talking about a decreasing interval. So we're looking where the graph is going down. We read a graph like we read a book from left to right, and we are looking for all of the x values, as you can see, in all of the answer choices. If we draw a straight line down, we can see that happens, oh, my line's a little off, 2.5, and that happens all the way to here, which is 5.5, so answer choice 3. The first thing that I notice about number 10 is that we are solving the quadratic equation and my roots are irrational numbers. So I either need to solve this by completing the square or the quadratic formula. Because the 4x is even, I'm going to go with completing the square, but the quadratic formula was also another good option. Here's the square completed. I found these two numbers because 2 plus 2 is 4, so that last missing piece of my square, which is right here, is plus 4. And if I add 4, I subtract 4. Then I'll group the -4 and -16 together. Here I've condensed it and moved the -20 to the other side. Take the square root of both sides. The square root of x plus 2 all squared is just x plus 2. When I take the square root of 20, I realize that that can be made a little bit simpler. So I have a perfect square factor of 4. And don't forget that this is a positive and negative root. So I have x plus 2 is equal to positive or negative 2 square roots of 5. Lastly, I'll bring the positive 2 to the other side to solve for x, and I get my final answer, which is answer choice 2. As soon as I see the word correlation coefficient in number 11, I know that I need to do a regression. So in this case, it's a linear regression, a linear fit. So in your calculator, you are going to type in all of these points. So my first point would be the point 1, 8. Then I would have 2, 8. Then I would have 3, 5, and so on and so forth. I'm going to do this with all of these points here. When I do that, I create a linear regression, and in my calculator, I should get a correlation coefficient. I do know that some of you might say, you know what, Mrs. Rousseau, I really don't have to do all that work because I know a lot about correlation coefficients already. That's even better. So that would be some great practice using your calculator. But some of you are saying this data is decreasing. So 1 and 2 are out because it's positive correlation, and we don't want that. We wanted a negative correlation. Our value points, our data points are going down. And is this data perfectly linear? It most certainly is not. So 4 is out of the picture. 3 is our winner. Moving on to 12, Keith finds zeros of a function to be x is equal to -6, and this is important to write it this way, and x is equal to positive 5. Well, we need to know what the function is, and the only way that this can happen is if we move that constant back to the other side where it started. So this would be x plus 6 equals 0, and this would be x minus 5 equals 0. So if you remember how solving quadratics works, you can take each of the roots and set them equal to 0, or each of the factors. So this factor gets set equal to 0, and this factor gets set equal to 0, but they're factors nonetheless. So we're going to look and see which one has a factor of plus 6 and minus 5, and that's answer choice 3. Another way to do this problem, for those of you that didn't like the math behind it, this is kind of like the shortcut I don't know if I want to say non-math way, but it's definitely not something that you could do on a part 2, 3, or 4 question. Let's put it that way. But you can guess and check. So in your calculator, graph this, graph that, graph that, and graph that, and figure out where the zeros, where the x-intercepts are -3 and 5. For question 13, the first thing that I like to do when I'm given values like this is just evaluate them in my calculator. So that's what you can see written to the right in purple. And a couple things to remember: anytime you take the square root of a number that's not a perfect square, like 2 or 3, we always want to put a dot, 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 because it indicates that those numbers, and let's also write this, are irrational. So there's an irrational number, another irrational number, and our last two are rational. They're numbers that can be written as fractions, or remember that any whole number or integer is always rational. Irrational numbers are numbers that don't end and don't repeat, or more importantly, decimals that don't end and don't repeat. So then down below, what we can do is actually just type into our calculators all of these expressions, L plus M, M plus N. You could either use the store key, or this is simple substitution. So if we evaluate all of these in our calculators, we can see that the only choice that represents a rational number, which we just talked about, a number that can be written as a fraction, is answer choice 3. Question 14 is asking us which system has the same solutions as the system below. So the good news about this is we can use the process of elimination to help us. When we have two of the same equations, that means the systems would have the same solutions. So we're looking for equivalent equations here. All right, let's start with this first equation. 2x plus 2y is equal to 16. Looks great in number 1 because it's identical. So we just need to make sure that the 3x minus y equals 4 is the same as 6x minus 2y is equal to 4. 3x times 2 is 6x, great. Again, we're multiplying the negative 1 by 2 and we get negative 2. So it looks like our multiplier is 2. Only problem is 4 times 2 is not 4, so answer choice 1 is out. Let's look at answer choice 3. We now have x plus y is equal to 16. So it looks like every one of our terms was divided by 2, except for the 16. If this had been an 8 here, those could possibly have been equivalent. So we're going to eliminate number 3. Number 4, let's see what happened here. 2 times 3 is 6, 2 times 3 is 6, 16 times 3 is 48. Awesome. 3 times 2 is 6. A negative 1 times 2 is a negative 2. Number 4 is out. Leaves us with number 2 as our correct answer. Let's just double check to make sure it's true. The first equation is exactly the same, so we don't need to check that one, but 3 times 2 is 6, negative 1 times 2 is negative 2, and 4 times 2 is 8. In question 15, it's asking us to model the table in a function. The first thing that you should recognize is as the x's increase, so do the y values, but they are not increasing at a constant rate. So therefore, we are not looking at a linear function. So answer choices 2 and 4 are out. The next thing that I would do for this question is graph f of x is equal to 3 to the x power, and f of x is equal to 2 to the x plus 1, and see which table of values is true. And answer choice 3, after you hit Control T, that would work out as well. Another less popular option would be to create a list and spreadsheet, type in all of this data, and do a regression. This would have been an exponential regression, and it would have also given you answer choice 3, 2 to the x plus 1. I'm hoping for question number 16, you created a table, a little chart, because whenever we deal with coins, this is typically what we do. Dimes and its value, and nickels and its value. So reading in the question, it says, John has 4 more nickels than dimes. Because of this, we know that John has 4 more nickels than dimes. So if dimes is x, nickels would be x plus 4. If we look at our equations now, we need to multiply the 10 cents times x, which doesn't look like it's happening in answer choice 1. It looks like it's happening in answer choice 2, not 3, and it's happening in 4. So this piece here. Now we're going to make sure that we're multiplying the 5 cents times the entire quantity of nickels, x plus 4. Remember, x plus 4 is not 4x. Therefore, question 4 is out, 2 is in. Looking at question number 17, the answer choices seem really scary, but they're not that bad. You just need to know that f of x is really the same thing as y values. And I'm just going to write this over any time I see f of x. So what do these mean? Well, we're given a function, a linear one, right here. Graph it and look at its picture. Change the window if you need to. Answer choice 1 says that y is always smaller than 0. So all of the y values are below the x-axis because this is where y is negative. Well, that's definitely not true. And it's not always positive either because if you see that the graph, as we go closer to negative infinity for our x values, it will drop below down here. So it's not always positive and it's not always negative. But let's see if we put some limitations on it. If x is smaller than 0, so if all of our x values that are smaller than 0, that's these guys over here, then y is always smaller than 0. Well, that's definitely not true. They're smaller than 0 over here, but not there. Let's hope answer choice 4 is correct. This is saying if x is larger than 0, y is always larger than 0. So here's where x is larger than 0. Will y always be above here? And the answer is yes.